Hello, you are most welcome. I'm teacher Ivan from WUNNA Educational Services. We are still continuing with the solving simultaneous equations, and we were looking at matrix method. This is our second example of how we solve simultaneous equations using matrix method. Please, if you didn't learn the first and other examples, please check out for the videos so that we move and enjoy together. You're most welcome. So we have 3x over 2 plus y equaling to 4 and x plus y equaling to 3. Before we go any further, we must eliminate this fraction first so that we simplify our solution. That is, from 3x over 2 plus y equaling to 4, we can decide to multiply throughout by 2 so that we get 2 into 3x over 2 plus 2 into y equaling to 4 into 2. This cancels with that to give us 3x plus 2y equaling to 8. And now, after eliminating the fraction, we shall bring our next equation, which is x plus y equals to 3. So x plus y equals to 3. We now have two ready equations to be solved. So, as we saw earlier in our previous example, whereby we generate the matrices, that is, we shall have 3, 2, we consider the coefficients of the unknowns, that is 1, 1, then x, y, the first one comes first, the second comes down, equaling to 8, 3. So we have generated our matrices. Now, another step is we get the adjunct or adjoint. Matrix from 3, 2, 1, 1, and that is, remember, our elements in the major diagonal change positions. 1 goes up, 3 comes down. Then the ones in the minor change signs. They are positives, so they become negatives. So after getting the adjunct, we shall now multiply the adjunct matrix on both sides of the matrices, but the adjunct should come first. That is, we shall have 1, negative 2, negative 1, 3, and 3, 2, 1, 1, xy equaling to 1, negative 2, negative 1, 3, 8, 3 from our previous matrices. we multiply the adjunct on both sides, but the adjunct coming first, so that we end up with such an equation where we shall multiply row by column, which will give us 1 and 3 gives us 3 plus negative 2 and 1 is negative 2. You come to the second column, that is 1 and 2 is 2 plus negative 2 times 1, which is negative 2. You come down, negative 1 times 3, that is negative 3, plus 3 times 1 is 3. Then on the second column, that is negative 1 times 2, which is negative 2, plus 3 times 1, which is 3. Then xy equaling to, still we do the same on this side, row by column, that is 1 times 8, which is 8, plus negative 2 times 3, which is negative 6. We go down, negative 1 times 8 is negative 8, plus 3 times 3, which is 9. So after generating, we now simplify, whereby 3 plus negative 2 is 1. This is 0, 0, 1 into xy equaling to, that is 2 and 1. When you add, end up with 2 and 1. So that is 1 plus 0. We are dealing with the upper row. 1 plus 0 into x equaling to 2. Hence that is 1x equaling to 2. We come down, that is 0 plus 1 times y equaling to 1. It gives us y as 1. Therefore, x equals to 2 and y equals to 1. So that is how we solve simultaneous equations using matrix C method. Otherwise, we meet next time. Please don't forget to subscribe.